Okay, now for the second part of our notes for day 12, which is on inverse trig functions, which we already used this before. When did we use it? Well, we used our inverse trig functions when we had a problem that looked like this. For instance, I might know that this side is 3 and this side is 5, and I wanted to find x. How would we have done that problem? Well, I would say this is the adjacent, this is the hypotenuse. Adjacent over hypotenuse is cosine x equals adjacent over hypotenuse. And then we would rewrite it like this with the inverse cosine. And then we'd use our calculator to find this angle. So what we were finding with the inverse cosine is we're finding the angle that goes with this cosine value. And we can do the same thing on a unit circle. So when I look at the problem number 10 here, what this problem is saying is go to the unit circle and find the angle where the sine is negative square root of 3 over 2. So let's do that. Let's go to our circle, and I'm looking for where the sine, that's the y value, is equal to this. Okay, I'm looking at the y values. That one's almost right, but it's not negative. Almost right, but not negative. Come around to the bottom. Oh, look, there's one. There the sine is negative square root of 3 over 2. So there's one answer. Notice our question says to give the answer in radians and degrees. So right here where the sine is this, the radians are 4 pi over 3, and the degrees are 240. But wait a minute. Is there another one on our circle? Look, it's right there. So which answer is right? Well, both of them are right. So I have to add not only this one on this side, but I also have to add this one on this side. So I'm also going to have this angle. Because the sine is equal to this on both of these angles. Is this going to happen on most of our problems where I get two answers like this? Well, if we remember that our unit circle is all about reflections, goes like this, and it goes like this as a reflection, it kind of makes sense that we're going to get two answers. Because everywhere I look, there's one on the other side that's the same. These two are the same. Or if I look at these two are the same. The only place this doesn't exactly happen is at the four corners, is at our quadrants here. Here, this is 1, and this happens to be a negative 1. Here, this is 1, and that happens to be a negative 1. So occasionally we'll get one answer, but in almost all these problems, we're going to get two answers. All right, so let's look at number 11. It says, find the angle where tangent is equal to 1. Well, where's that going to happen? Because tangent is y over x. The only way that y over x can equal 1 is when the same thing is in the numerator and the denominator. Well, that happens in two places. The x and the y are the same right here and right here at the bottom. So at my 45 and at my 225. So I'm going to take those two and I'm going to put them on my answers. 45 degrees and 225 degrees. I'm also going to write down my radians. That's pi over 4 and 5 pi over 4. Okay, the next one, inverse cosine, negative square root of 2 over 2. Well, cosine is my x value, so I need to look at my x's. And I'm looking for the negative. Here's one right here. And if I keep looking around, I also find the other one right here. So here I'm looking at 135 and 225. And that corresponds to 3 pi over 4 and 5 pi over 4. Okay, cosecant, inverse cosecant of 2. So cosecant is the inverse of sine. So I'm looking for where the sine is the reciprocal of this number. So I'm looking for where the sine is 1/2. So I look over here and sine is the y value. Well, that happens right here at pi over 6. And it also happens on this side at 5 pi over 6. So let me put those on my paper. Pi over 6 and 5 pi over 6. That's 30 degrees and 150 degrees. Okay, our next column, inverse cotangent. Okay, inverse cotangent is the reciprocal of tangent. So if I reciprocal the tangent, I get 3 over the square root of 3. Well, that doesn't look like anything that's on my paper over here. But this, if I rationalize the denominator, what I get is the tangent of 3, square root of 3, I'm going to write it right here, over 3. Well, when I reduce that, these reduce, and I just get the square root of 3. So now I'm looking for where the tangent is just the square root of 3. Well, I know the tangent is y over x, so it has to be over something, so it has to be over 1. So I'm looking for where the y is square root of 3 and the x is 1. Well, this happens, does it happen here? No, this is the x is 1, this is backwards. It happens right here. The sine is square root of 3 over 2, and the cosine is 1/2. When I divide those, I'll get this answer right here. So this happens at pi over 3, or 60. And does this happen anywhere else? Well, it actually happens over here on this one. They're both negative, so that makes a positive answer. Still, y over x makes square root of 3 over 1. So it also happens at 4 pi over 3 and 240. Okay, our next one, cosine of -1. Well, cosine is my x value. It happens right here. Even though it's cut off with the hole, it's -1 right here at 180. Is there any other place this happens? No, because this is one of the special ones. That side is +1. This is the only place it happens. It happens at pi or 180. Okay, inverse sine of -1/2. Well, sine, these are positives for sine. Here we go. Sine is -1/2 here and -1/2 here. 210 and 330. Which is the same as 7 pi over 6 and 11 pi over 6. Okay, now we have an interesting thing here. This says the inside part says find the angle where the sine is 1/2. So the sine is 1/2 right here at 30 degrees. So I'm going to put that inside here. And now this says, well, what's the sine at 30 degrees? Well, it's actually 1/2. But we know this is 30 degrees is not the only place that this happens. It also happens right here on this side at 150. So I could do the sine of 150 degrees, but wait, the sine of that is still 1/2. So what is the rule if I have this sine and the inverse sine? Well, those are inverse functions. They cancel each other out. This is exactly how we solved those triangles before. If I have the same ones here, they cancel each other out. Now look at the next one. Will it be true here? Will cosine cancel out negative, the inverse of tangent? No, those are not the same, so they're not going to cancel out. So I do these the same way I did the last one. First I find, well, where's the tangent 1? Well, the tangent is 1 here, and the tangent is 1 here. So pi over 4 and 5 pi over 4. And I can use radians or degrees on this. I'm going to go ahead and use the radians that I started with, pi over 4 and 5 pi over 4. So I've got pi over 4, and I've got 5 pi over 4. And now I want to know what's the cosine in each one of these things. Well, here, the cosine happens to be the x value, so it's square root of 2 over 2. But here on this one, is it the same? No, the cosine here happens to be a negative. So my answer is negative square root of 2 over 2. You could leave your answer like that, or how else could we write it? Well, we could use the little plus or minus symbol. And we could write it like that. Okay, let's try another one of those. The sine at pi, well, here's pi. The sine at pi is 0. And notice this one is actually the sine at pi, not the inverse. So this says the sine at pi. Well, the sine at pi is 0. Now it says, where is the tangent equal to 0? Well, tangent is y over x. So here, will that be 0 for tangent? Yes, this will be y over x is 0. So it happens at 0 degrees, or 0 radians. Does it happen anywhere else? It also happens over here, because 0 divided by negative 1 is also 0. So it also happens at pi and 180. Okay, our next one. Now it says take the tangent of pi over 4. Tangent of pi over 4, that's here. Well, tangent is y over x, so that's 1. And now it says to do the inverse secant. Where is the secant 1? Well, the secant is the inverse of this of 1. Well, the inverse of 1 is still 1. So this is going to be the same place where the cosine is 1. Well, where's the cosine 1? This actually only happens one place, right here, at 0. 0 degrees, 0 radians. And then we have a fun one where they've started stacking up more and more stuff. But just remember, it's just like every other problem. Remember your PEMDAS, start at the middle parentheses and do one step at a time. Sine of pi over 2. Sine of pi over 2. Here's pi over 2. The sine is 1. So this is 1. And then bring down each step. This is not the time to start skipping steps and not write everything down. Okay, now I want to know, where is the tangent equal to 1? Well, the tangent is equal to 1 right here and right here. So at pi over 4 and 5 pi over 4. So I actually break this into two problems here, pi over 4 and cosine at 5 pi over 4. Well, what's the cosine here? Well, that's square root of 2 over 2. That's at pi over 4. And what's the cosine at 5 pi over 4? Well, that's negative square root of 2 over 2. And once again, I could write it like this, or I could write it like this. Both are perfectly acceptable. And that's the end of our notes. Thank you.